What causes turbidity currents to form underwater canyons? Imagine a river of muddy water rushing down the side of an underwater mountain. That's what a turbidity current looks like, but beneath the ocean's surface. These powerful flows carve out deep underwater canyons over time. But what triggers these sudden, sediment-laden floods? It all starts with the movement of dense water filled with tiny particles like sand, silt, and clay. When these particles mix with seawater, they make the water much heavier than the surrounding clear ocean water. This heavy mixture begins to flow downhill along the slope of the ocean floor. Several things can set off this process. Earthquakes are a big cause because they shake loose sediments on the continental slope, causing underwater landslides. These landslides create a quick, heavy flow of sediments that rushes downward. Storms and hurricanes also play a role by stirring up sediments on the continental shelf. When waves are strong, they lift and suspend sediments, pushing them toward canyon entrances. Rivers that carry large amounts of sediment during periods of low sea level can also supply enough material to start a turbidity current. When rivers deposit sediments at the canyon head, the mixture becomes dense enough to flow downward. Slope failure happens when sediments pile up too quickly or become unstable. If the slope becomes too steep because of rapid sediment buildup, it can collapse, sending a surge of water and particles into the deep ocean. Seismic activity, like earthquakes, can destabilize sediments on the slopes, causing underwater landslides that turn into turbidity currents. Once these currents start, they race down the canyon at high speeds, sometimes reaching several meters per second. As they move, they carry sediments from shallow areas into the deep sea, shaping underwater landscapes and forming deep-sea fans. These flows are episodic, meaning they happen suddenly, last for a short time, and then stop. They are a key part of how sediments are transported from the coast to the deep ocean. Understanding what causes these currents helps us learn about water quality parameters like turbidity, which measures how cloudy water is due to suspended particles. It also helps us understand how pollution and sedimentation affect marine ecosystems and underwater infrastructure. So, in essence, turbidity currents are driven by a mix of geological, hydrological, and oceanographic factors that work together to shape the underwater world we see today.